सो आप लोगों को तकलीफ हो रहा बोल के नीचे डाल दिया, ऊपर चढ़ना है ना, 2 floors. यस, बट एनीवे so this is a global keyword, right? And we have seen non-local and even I said what is LEGB and generators. Okay, so your generator is having okay, generator is having one. So every function is not called as a generator. The function which is having which keyword? Yield keyword, right? Which is having yield keyword, and that you call it as which function? Generator function, right? So this will return generator iterator. For example, assume that, yes, we'll try to see. Okay, so for example, I want to I want to create a generator function. Suppose I want to write a generator function. So I want to write a generator function. So I want to write a generator generator function. So write a generator function. So write a generator function which generates what here? Prime numbers. Okay, write a generator function. So that will generate which numbers? Prime numbers. So generator function is, I said it is similar to range, but it is custom range. Means you can generate the sequence of values by using which one? Generator function. You can generate the sequence of values. For example, the name of this function is some prime generator. What is the name of the function? Prime generator. And this function receive two values. One is m and one more is a n. So m is nothing but a start value and n is nothing but what? Stop value. So this function takes how many inputs here? Two inputs. So first one is m and second one is what here? N. So m is a start value and n is a stop value. So after that, it should generate the values from m to n. So for a number in range m comma n plus 1. So here I try to include n also. For example, if I'm calling the prime generator function, if I'm saying p equal to prime generator, and if I'm trying to write some 4 comma 10. So what I want is I want to generate the prime numbers from 4 to what here? 10. So what is the value of m here? 4. And what is the value of n here? 10. So this for loop will generate how many values? From 4 to 10. So here the value of m is 4 and the value of n is 10. 10 means here it takes what? 10 plus 1 means 11. So this will generate all the values from 4 to 11. Then I have to find out whether 4 is a prime number or not. 5 is a prime number or not. 6 is prime number or not. So for that, I have to count how many times that a number is divisible. So I've taken one counter and start counting it for I in range of, so 1 comma number plus 1. Suppose if my number is 4, this will generate 1 comma 5, means 1 2 3 4. So you are dividing it. If number mod 2, number mod I equal to which one? 0, then you are saying count plus equal to 1. So this is a logic for finding the prime number, right? So the number is, here it is like this. The value of m is 4 and the value of n is what here? 10. So this will generate the values from 4 to 10. Means 4, okay, 5, 6, 7, 8, okay, 9, 10. So what is the first value in the range? 5. What is the value of number here? 5. So the value of count is what here? 0. Now this will generate, okay, how many values? 1, 2, 3, 4. So it means you are dividing 4, how many times here? 4 times. That is 4 mod 1 and 4 mod, what is that here? 2 and 4 mod 3 and next one is 4 mod 4. So how many times it is divisible? 1, 2, 3. Then 4 is not a prime number because how many factors are there? 3. More than 2 or not? Yes. So the number which is divisible with 1 and itself, so that you call it as prime, right? But this 4 is divisible with 1 and 4 is what here? 2. So it is not a prime. Then if outside the loop I am writing if count is 2. Outside the loop I am writing if the count is 2, what I am doing, I am trying to say yield. What I am writing here? Yield. So yield, what is the value I am returning here? Number. If the count is 2, now you are returning number because that number is which number? Prime number. You are returning number because that number is which number? Prime number, right? Yes. So this will generate all the prime numbers from 4 to 10. Now you can give for, okay, for some x in P. So P is nothing but generator iterator object. Generator iterator object, and this will iterate all the values generated by which function? Prime generator. It will iterate all the values generated by prime number. Again, see how many numbers are there? 2 numbers. One is 5 and one more is a 7. In the same way, you can define number of values here. So I can create one more prime generator. So prime generator, and you can define the start value is 5 and stop value is some 20. Then I'm trying to say for y in a q. So this q will generate all the prime numbers from all the prime numbers from 5 to 20. You can see 5, 7, 11, 13, 17, and 19. So all these are called which numbers now? Prime numbers. So it means if you want to create your own function that will generate a series of values. I want to create my own series. Or generator. So for that, you are using generator function. And generator function, always it returns a value by using which keyword? Yield keyword. Generator function always, it will return the value by using which keyword? Yield keyword it uses. Okay. It uses yield keyword and return the value. Right? So this is the output of the code here. Okay, so this is called as a prime generator. Okay, this is called as which one? Prime generator, right? Okay, right? So then you can have your own generators. Okay, like suppose I want to generate a random numbers. I want to generate random numbers between the given range. I want to generate random numbers between the given range. Then you can write one generator. And what is a generator? A random generator. You can create. So one function. So you want to generate random numbers from which range to which. Suppose random. Okay, random number generator. So I try to give the start value and I try to give which one? Stop value. So I've given how many values here? Two values. So one is a start and one more is what here? Stop. So here I'm trying to use one predefined module for generating random number. And what is that predefined module I use is random. So this module will provide one function for generating random numbers. Okay, this function will provide. Okay, this function will provide. This module will provide one function for generating random number. So random integer. So what is the name of the function? Random integer. So to this random integer, I just give the start value as well as what? Stop value. So your random generator takes how many values here? Two values, that is a start and stop. And inside this random generator, you are using which function? Random integer function. And this random integer function generate the random number between the start and stop. And after that, you are returning that number. So yield that number. Okay, I said yield number. But if you want to generate, okay, so it will generate how many values here? Only one value. If you want to generate number of values, then you put this inside one loop. So I just write here while true. While true means, is it this loop is infinite or not? Yes. Now this will generate infinite random numbers between the start and stop. If I don't write inside the loop, then this random generator generate how many values? Only one value. One generator will generate only one value. But I want this should generate what? Infinite number of values between the start and what is that? Stop. Then you are using random generator by giving how many inputs here? Two inputs. One is a start and there's one more input is given and what is that? Stop. So there is a function main here. Now I'm trying to write random generator. So this is creating generator iterator object. I want to generate all the random numbers from 5 to 10. Okay, so this is infinite. This is infinite here. So how can I get each time one value? By calling which function here? Next function. Because here what is RG is a variable of type generator iterator. And how can you iterate values from generator iterator? By calling which function? Next function. So next function read the value generated by which one? Iterator object. And this iterator object read the values from where? The function called random generator. So I just said next of random generator. And I said value 2 equal to next of random generator. Now this will try to generate how many random numbers? Infinite random numbers between 5 to 10. Because there's no stop for that. Because there's no stop for that. Now you can see the value is a 6 and what is that? 6. But don't think that always it gives a value 6 only, right? Now I'll try to say value 3 equal to next of random generator and I just write the value, what is this here? 3. Now when you run this, what is the value randomly? 5 and 10 again is generated which one? 5. So because these values are generated how? Randomly. But how this random generator is generating values randomly? By using one function. What is the function it is using? Random integer. And this random integer is a function of which module? Random module. Random integer is a function of which module? random module and that will return. But how generator returns value by using yield, and yield will pause the execution of function. After returning value, it will pause the execution of function. When you call the next method, it will resume back and start executing again. But return statement will return the value. Yield will return value, return also return value. But yield return value and pause the execution of function, and return the value but terminate execution of function. Okay, it will terminate execution of function. That is where you find the difference between the yield and what is that return. So like this, you can generate any generators. That is based on your application requirement. You can generate any generators. Okay. Okay. Now this is the output here 5, 5, 5, 10, and what is that? 5. So this is called as which function here? Generator function. So generator functions are customized range functions, right? So this is an example of generating. Okay, generating which numbers here? Random numbers. Generating random numbers between given range. Generating random numbers between given range. Generating random numbers between the given range. So generating random numbers between the given range. So that is done by using this here. Okay, right. So the next one is, there is one more special function is there called which one? Decorator. What is the name of the function here? Decorator. So what is a decorator again? Decorator is a special function. Okay, what is decorator is? Decorator is a special function. It is a special function in Python. Decorator is a special function in Python. And decorator is a nested function. Decorator is which function here? Nested function. So what is the meaning of nested function? A function inside the function is called what? Nested function. So what is a decorator? Decorator is a nested function. Decorator is a special function in what? Python. And decorator is a nested function. Nested means a function within the function is called which one? Nested function. If you are writing a function inside a function, then you can call that as which function? Nested function, right? So decorator, okay, decorator is used. Decorator function is used, okay, to extend functionality, of existing function. To extend functionality of existing function without modifying it. Decorator function is used to extend functionality of existing function without modifying it. So that is done by using which function here? Decorator function. So extending functionality. Or even you can use decorators. Decorators are used to transform one function, to transform one function to which one? Another function is done by using which function here? Decorator. It's nothing but function transformation is done. Function transformation is done using which one? Decorator. Decorators are used to transform one function toward another function. Function transformation means one function you write and you want to convert that function toward another function, or you want to add some extra features. Okay, extra features to that function, then you can go for which one? Decorators. If you want to add some extra features, if you want to extend the functionality of existing function without modifying it, then you can go for what here? Decorators. Adding extra functionality to the existing function is done by using which one? Decorators. So I said it is a nested function. It is a nested function. Now what is a Python definition of decorator is? Now this is a document definition of decorator here. So what is a decorator here? Now this is document definition of the meaning of which one? Decorator. A function returning another function. A function returning another function, usually applied as a function transformation using wrapper syntax. And Python provides some predefined decorators like class method, and one more is what? Static method. All these are called predefined decorators. Now, this is one more definition. A function returning another function. So this is a Python definition, Python document definition. A function returning another function. A function returning another function. A function returning another function, usually applied as a function transformation using wrapper syntax. Now, common examples for decorators are like you have a class method and there is which method? Static method. So these are called which one here? Decorators. These are general decorators. Okay. A function returning another function, usually applied as a function transformation using wrapper syntax. Common examples for decorators are like class method, and one more is what? Static method. Okay, I said decorator is a nested function. Nested function means a function returning another function. For example, so just try to see this one. So it's nothing but decorator is a function which takes the input as one function and return another function as what? Output. So this is one more definition. Decorator function, okay, takes input as one function, and return another function, as what here? Output. It takes the input as one function. Decorator function takes the input as one function and returns another function as what here? Output. Even that you can do it by using which one? Decorators. So that is also done using which one? Decorators, right? So how this decorator is? It is like this. For example, I write one function. Okay. For example, there is one function. Okay, assume that there is one function called function 1. Okay, there is one function called which one here? Function 1. And where I'm trying to display the message inside function 1. Where I display the message inside function 1. And I call this function 1 here. So how many executable statements are there? Only one. So you are calling which function here? Main function. And main calls which function here? Function 1. So how many executable statements are there in your program? Only one executable statement. And what is that executable statement? Main. So which one is called here first? Main. And main calls which function? Function 1. And what is the message I'll get inside function 1? Is it execution of function 1 is completed? Yes. Then is it execution of main is completed? Yes. Then is it any statements to execute here? No. It will stop. So what is the output I'll get here? What is the output inside function 1? What is the output I'll get inside function 1? So inside function 1, what is the output I'll get here inside function 1? Inside function 1. Now this is output. So inside function 1 is called as an output. Inside function 1. Now this you can call it as which one? Output. Now I want to decorate this. I want to decorate means I want to add one more functionality to this particular function. Means I want to decorate which function? Function 1. For decorating the function 1, what I'm doing? I'm writing a decorate. I'm writing one decorate. I want to decorate which function? Function 1. I want to decorate which function? Function 1. Decoration. Decorator. Now you have a gift. Gift. This is a gift, right? Gift is what now? Function 1. This gift is what here? Function 1. Okay, it is just like a wrapper. Decorator is like wrapper. Okay. So I want to decorate this. Then I wrap this gift inside what? Another function. Okay, so this is a wrapper. This is a wrapper where you are wrapping. This is a wrapper where you are wrapping this function or this gift you are wrapping inside one wrapper. Okay, it means are you adding some new features to this or not? Yes. To this gift, you are wrapping inside one wrapper. Okay, you are decorating it by wrapping inside one wrapper. So this wrapper is what now? Decorate. Okay, now this is another function you are writing it. So definition function 2. What is this function 2 here? Wrapper, or it is a decorator. This function 2 is decorating what? Another function. Okay, so it will take this function 2 as input as what? This function 2 takes input as one function. So f is what here? Argument name. F is what here? Argument name. Argument name is a variable or not? Yes. You can give any variable. You can write A, B, C, D, E, F. Any variable name you can use it. But what is the name of my variable here? F. Now because this function 2 takes the input as what here? Function. Okay. So which function? This takes the input as which function? The function which has to be decorated. Suppose if you want to decorate function 1, then this function 2 takes the input as what? Function 1. If you want some other function should be decorated, then this function 2 takes the input of that function. So function 2 takes the input as one function. It takes a function as an input. It takes the input as one function. And after taking the input as function, okay, so which function? The function which has to be decorated. Then you have to decorate this function or not? Yes. So we send this function 1 to what? Function 2. Then this function 1 should be decorated or not? Yes. Decorated means you should transform that function 1 into what? Another function. You have to transform that function 1 into what? Another function, or you should add some new features. Then what I'm doing is I'm writing here another function. So why this function is? This function will decorate which function? Function 1. This function will decorate which function? Function 1. So I'll try to say this function is what now? New function 1. So new function 1 is having new function 1 or new function. Okay, this is new function. This new function is having features of which function? Old function. Decorated function, as well as I just display one message. Now this is which one? Decorator. This is which one? Decorator. Okay. And I said decorator is a function. Decorator is a function which takes the input as one function and return another function. So which function it is returning? New function. So what we did here, we decorated one function. Whichever function it is received, that function is decorated by including in which function? New function. We decorated the input function by including in what? New function, and returning which function now? New function. Then now I want to decorate the function 2, and I'm decorating the function 2 by using which one? I want to decorate the function 1 using which one? Function 2. It means function 1 is wrapped. At the rate means what? Wrapper. At the rate means what? Wrapper. I'm wrapping the function 1 inside what? Function 2. What is the meaning of this? I'm wrapping function 1 inside what? Function 2. Which one is sent as input to the function 2? Function 1. What will happen here is it will send the input as a function 1 as input to what? Function 2. Now what is the f now? Function 1. And then returning which function now? New function 1. Means is it executing internally function 1 or new function? New function. And this new function is having functionality of which function? Function 1. Because f is nothing but which one? Function 1. And function 1 is displayed which message? Inside function 1. And it is also add one new message or not? Yes. What is that new message? Decorated. What is that new message here? Decorated. Right? So wrapper is nothing but wrapper at the rate function 2 means now you are trying to wrap this function 1. You are trying to wrap this function 1 inside what here? Function 2. You're trying to wrap this function inside what? Function 2. It means you are sending this function 1 as an input to which one? Function 2. Function 2 receive the input as one function. After receiving the input as one function, it is returning the output as another function or not? Yes. And this function you are wrapping inside one function, right? Now what is that new function? That is a new function or not? Yes. So inside the new function you are including the features of decorated function or not? Yes. And it is also having some new features. Now internally, is it called the same function or new function? New function. Because it has been decorated. You can see inside function 1 and one more is what? Decorator. If I don't write this, I just call only which one? Function 1. But I want to decorate it. I just use a decorator by using at the rate wrapper, at the rate, and it followed by which name? Decorator name. And what is the name of the decorator? Function 2. And to this function 2, input is given as what? Function 1. And this function 1 is included in which function? New function, and return a new function as the output or not? Yes. So new function, this is new functionality, and this is what? Old functionality. Old functionality is included or not? Yes. And after that is returning the new function. So that is extending the functionality or transforming one function into what? Another function. You are changing one function into what? Another function with the help of what here? Decorators. Now you can apply these decorators. Now there is another function called function 3. There is a function 3 and I said inside. I just write here inside. What is inside here? Function 3. I called which one now? Function 3. I call the function 3. You can see inside function 1, decorator inside what? Function 3. But I want to decorate this function 3. I'm using at the rate. What is this here? Function 2. It means function 3 is decorated with what now? Function 2. Okay, it means function 3 is wrapped inside what? Function 2. Inside the function 2, function 3 is wrapped or not? Yes. Okay, now if you run this, you can see this is inside function 1 and decorator, and inside function 3 and what is that? Decorator. Inside function 1 and decorator, and inside function 3 and decorate. Decorators are very much helpful when you are learning like web applications, or if you are working with certain tools. Okay, so when certain tools will generate some code based on the decorator. For example, I'll tell you. One more example where these decorators are reusable and can be used either with one function or more than one function. Can be used either with one function or more than one function. For example, okay, for example, So for example, there is a for example, there is a function. There is a function called, assume that there is a function called some, suppose assume that there is a function called concatenate. Concatenate is a function, and this function receive a number of strings, okay, and do the concatenation and returns, okay. It receive the number of strings and do the concatenation and what returns. But how you do the concatenation? Okay, suppose you take another string. What you are doing, you are taking another string. Okay, another string you are taking. So this is called as which string now? Output string. This is the output string. Okay, now, and you are trying to join it by saying s1 dot s1. Sorry. You are taking another string and you are just doing joining, right? So join with this string, but separated with what here? Space. I want to join all these strings by separating with what here? Space. So what will happen? It will take all the strings and join with the space and return into what here? S1. So return S1. Okay. So then this is a function. This is a function what here? Main. As a function main now. Now where I want to concatenate some strings. Okay. So I try to say result one equal to concatenate. So I'll try to send number of strings. Okay, I just write here. So first string is Python. First string is Python and second string is what? Language. Then it will concatenate and return the result as what here? Python language. It will return the result as what here? Python language. It will return the result as Python language. Now you can see Python space and what is that? Language. Is it this both the strings are concatenated or not? Yes. Now I want this after doing concatenation. I want some concatenation. After concatenation, I want this result should be written in uppercase. Okay, some functions are there and some function returns the result as it is. Okay, there is a function called concatenate. There's a function called which one? Concatenate. Like this, there are so many functions are there which will do certain operations on the string and return what? Result. Suppose I'm developing one decorator. I'm developing one decorator called which one? Upper. Okay, now whichever string function want to return result into which case? Uppercase. Then I decorate with which one? Upper. I decorate with which one? Upper. So definition, what is the name of the function? Upper. Upper is a function which receive the input as one function. Which receive the input as one function and return output as what? Another function. What is this function now? Upper string. This function is which one? Upper string. Upper string is a function. Okay, upper string. What is the name of this function? Upper string. But so the outer function is what here? Upper. And inner function is what here? Upper string. Now what this function is? Now this function will convert this input. Whatever input is given, this input it should convert into which case? Uppercase. It should convert this into which case? Uppercase. So this is the function which is transforming it or not? Yes. And this function and the function which you are transforming, both functions should have the same number of arguments and same types of arguments. Now I'm writing upper string and star is. And this function is calling, which function? Concatenate function. This function is calling which function? Concatenate function by sending which one? Yes. By sending which one here? S. By sending S. S is nothing but tuple or not? Yes. By sending S. It is calling this function by sending S. S is a tuple and star S is nothing but packing or unpacking. Unpacking. Star S is nothing but packing or unpacking. Unpacking. Now can you send only S? S is nothing but tuple and you are sending the values of tuple, right? Okay, you are sending which one? Tuple. In the place of tuple, can you write star S or not? Yes. What will happen if I write S? Now this, yes, we'll take this as a output here, and this output you are returning, this output you are converting into which case? Uppercase. Output dot upper and return which string here? Upper string function. Return which function here? Upper string function. But this is without using decorator, and I'm using a decorator at the rate. What is a decorator I use? Upper. I use a decorator as upper tuple. So I send only S, right? You have to send what here? Star S. Now you can see Python language. If I'm not using this decorator, what will happen? If I'm not using a decorator, now this function returns the value as a Python language. After concatenating, is it returning? After concatenation, is it returning the result as Python and what is it? Language. Is it this two strings are joined by using which function? Join function. Already we have seen this in strings. So these two strings are joined by using which function? Join function and return which value? S1. What is the value of S1? Python language. But I want this output should be in which case? Uppercase. Then you decorate it. Then you decorate it by using which decorator? Upper. Then you decorate it by using which decorator? Upper. So what this upper will do is it will receive, this upper will receive which one? Function. Which function it will receive? Concatenate. Which function it will receive? Concatenate. This will receive. Which function will it receive? Concatenate. It will receive which one? Concatenate function as input. It will receive the concatenate function as what? Input. Okay, input, and then yes, concatenate function as input, and this function output you are transforming it using which one? Upper string. And when you are writing this function, you have to follow the rule. What is the rule is the inner function are transform function and decorated function both must be have same what number of arguments or types of arguments. Is having which arguments? Variable length. And upper string is also having which arguments? Variable length. Because it is calling which function? Upper string. It is returning upper string, right? Now internally it is calling which function? Upper string by sending these two values or not? Yes. And these two values are sent to which function now? Concatenate function. And concatenate function is joining and returning into what? Output. And this output is written in by converting into which case? Uppercase. Getting or not? Okay. Now suppose, assume that there is one more function is there. Concatenate. Concatenate with the separator. Now here there is no separator used, right? Only space is used. But here I can send it. Star yes. Star S and there is a separator here. There is a separator and default separator is what now? Space. What is the default separator I use here? Space. If I don't give a separator, it takes a separator as what now? Space. Or any function you can take. So don't think that you have to give only this, right? Any function. But why again concatenate? So we'll try to see some other string function where it returns a result in string. Where it returns a result in what? String. Where it returns a results in string. Okay. So what we'll do? Another function means Any function which return the result in string, which return the result as a string, right? Which returns the result as what here? String. So any function you can take it. Now, what is this function is? So returning vowels, returning vowels from where? String. But this should return number of one or more than one string. So returning vowels, but this is having of type which one here? Star. But returning vowels, anything otherwise. Why? Because I say no, this function and this function should have a same. I mean the function which returns more than the function which receive more than one value. The function which receive more than one value. The function which receive more than one value. Suppose display is there. There's a function display, and this display function just display all the strings. Okay, display all the strings, display all the strings. So what this function will do is it will receive all the values. It will receive all the values and return all the values. It will receive the values and it returns what here? All the values by using some separator. Okay, no problem. So just try to understand with this, otherwise. Why complexity here? Concatenate. But you understood this concatenate here, right? So this concatenate is joining all the strings and returning one string. I'll tell you one more example, otherwise. So this is converting the output into which case? Uppercase, by using @wrapper called which one? Upper. By using @wrapper, and @wrapper is nothing but what here? Upper. So by using @wrapper, and that is nothing but upper here. So there is now number of examples you can write, but first you have to understand what is a decorator is. First you have to understand what is the need of decorators, like adding some new features to the existing function. So adding some new features to the existing function, what here without modifying it. Now this output is what now? Python language is in uppercase or lowercase? Uppercase. For example, assume that there is one function. These are very much useful in application development. Okay. These are very much, this will reduce the code. Decorators will reduce the code. You don't require to write the same thing again and again. You just apply which one? Decorator, to transfer one function toward another. Getting on it. So if you don't want, you just remove that decorator. If you want, you add that feature. If you want, you just add that feature. If you don't want, you just remove that particular feature. Okay, now that is advantage of using what? Decorators, right? So there is a, assume that, okay, there is a function called division. Okay, there is a function called what now? Division. And division function takes the input as two numbers. Division takes how many values now? Two values. So that is n1 and n2. What is the job of division? Just dividing two numbers and returning the result, right? So return which one? Result. So R is nothing but result or not? Yes. So what is the inputs for this division function? Two numbers. Now it receives the two numbers and divide it. And after dividing it, what it do? It will return the result. Okay. So there is a function main here. So result 1 equal to division. I just give division, or I just input two values, otherwise number 1 equal to input, enter first number. I said enter first number 2 equal to integer of input enter. What is this second number? So you are trying to input how many numbers here? 2 numbers. So enter first number and enter what? Second number. After entering first number and second number, you do which operation? Division by sending how many values? 2 values. So that is number 1 and number 2. So after that, I print the result by saying result is, I print the result with how many decimal places? 2 decimal places. I print the result with how many decimal places? 2 decimal places, right? Now this is what exactly? But are you use any decorators here? No, not use any decorators. Now once you run this, it's asking enter the first number, which is 4, second number is 2, and you can see the result is 2.00. Fine. If I run this, okay, enter first number is some 5 and second number is 2. What is the result now? 2.50. Okay, then I try to execute again. Enter first number is 7 and second number is what? 0. Then immediately it is given error. Immediately it is given. What is it error? It is given 0 division error. 0 division error and division by what here? 0. 0 division error and it is given error. What is it? Error is given division by 0. Okay, so it means you cannot divide a number with what? 0. If you are trying to divide a number with 0, then it rises what? Error. Okay. If you are trying to divide a number with 0, then it rises what here? Error. Right? Okay. Okay. Okay na? అయిపోయిందా? ఏందమ్మా? అన్నిసార్లు ఓకే అన్నా కూడా నువ్వు నాకు చూస్తలేవు. అంత దాని లోపల వెళ్ళిపోయినావు. అదే పైథాన్లో వెళ్ళావు అనుకో, ఫ్యూచర్ బాగుంటుంది. అంత కాన్సన్ట్రేషన్ పైథాన్ మీద చేసినావు అనుకో, అంత డీప్గా పైథాన్ ఆలోచిస్తారా? మొబైల్ మొత్తం లీనం అయిపోయింది. అసలు ఓకేనా 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 3 సార్లు అన్నానా? చూడలే ఆయన. అంత డీప్గా వెళ్ళిపోయింది అన్నట్టు. అదే పైథాన్ వెళ్ళమంటే వెళ్తాడా? అస్సలు సచ్చినా వెళ్ళాడు. అదే పైథాన్ వెళ్ళాడు అనుకో, ఈ పాటికి జాబ్ వచ్చేస్తుండే. అవునా కదా? అట్లనే ఉంటుంది. ఓకే, సో మనం ఏం చెప్పుకున్నాం కూడా నచ్చలేదని అంత లోపలికి వెళ్ళిపోయింది. ఓకే, వాళ్ళ క్వశ్చన్స్ అడిగితే ఫీల్ అవుతారు. అది కూడా అడగద్దు. మళ్ళీ స్టూడెంట్స్ ఎట్లున్నారంటే, హౌ స్టూడెంట్స్ ఆర్, I should not ask questions. If I ask the questions, they'll feel. సార్ నన్ను క్వశ్చన్స్ అడుగుతాడా? ఏంది ఎవరిని అడుగుతాడా? నన్నే అడుగుతాడా అంటాడు. నా మీద ఎందుకు అంత కోపం అంటాడు. కసి, కక్ష, కోపం ఇంకేముంటుంది చూడు అట్లా. అందుకోసం క్వశ్చన్స్ కూడా అడగడం మానేశాను నేను. ఎందుకంటే ఇప్పుడు స్టూడెంట్స్ వాళ్ళు పెద్దగా అయిపోయారు బాగా. So we cannot ask any questions also. If we ask the questions, right, they'll feel ego. ఇంకేమంటారు చూడండి, చాలా ఉన్నాయి మీకు. అవన్నీ వచ్చేస్తాయి బయటికి. వచ్చేసి రేపటి నుంచి రారు. రాకపోతే ఎవరి గురించి? నా గురించా? మీరే లాస్. అవన్నీ వెంచేసుకుంటారు. సార్ నన్ను క్వశ్చన్ అడిగిన అంటే రేపటి నుంచి రారు. రాకపోతే ఎవరికి లాస్? నాకు లాసే. నేను ఎట్లా ఒక్కరున్నా కూడా చెప్తా, చైర్లున్నా చెప్తా. అవునా కాదు? సో స్టూడెంట్స్ అడ్లు ఉన్నారు. ఏమనద్దు స్టూడెంట్, ఏమనద్దు. రావాలి, కూర్చోవాలి, పోవాలి. మొబైల్ చూసినా కూడా ఏమన్నది. అట్లా. సో కాబట్టి అట్లా అయిపోయింది, ఏం చేయలేం మనం. ఓకే, మార్చలేమన్నట్టు. సో 2.67 is the answer here. But anyway, when you run this, but what will happen 8 and 3, what is the result? 2.67. But I try to enter some 7 and 2, and that value is what? 3.50. Okay, but what will happen if I try to input the number as a 8 and some 0 as a denominator, right? Then immediately it rises which error? Zero division error. Okay, what is the error? It is displayed zero division. Okay, it means this function doesn't divide. This function doesn't divide a number with what? Zero. Okay, now this function will not divide a number with a zero. Okay, it will not divide a number with zero. Then I want to add some new features to this function. Then I'll try to develop another function. I'll develop another function, and what is that function is smart division. Okay, there's one more function is there. Smart division is a function, and the smart division is a function which takes a input as one function. Smart division is a function which takes input as one function. Which function here? Division function. It will take the input as which function? Division function. And to this division function, you should add some new features or not? Yes. Then I should write one more function. And this is a transformed function. So you are returning which function? A transformed function. That transformed function is which function now? Inner function. So this is a division 1. Okay, division 1 is a new division. So this division 1 takes input as what? N1 and N2. And it will verify if N2 equal to 0. If N2 equal to what? 0. N2 equal to 0 means denominator is 0. Then I'm saying return what? 0. Otherwise what I'm saying? I'm calling the old function. F means what here? Old function. Decorated function. Which one is decorated here? Division function. F is nothing but division function. And to that division function, I'm sending the value of N1 and N2. Otherwise, it will return 0. Otherwise, it will call which function? Division function by sending N1 and N2 values and find the result and return the result here. And from here, it is returned to which function? Main. So this is a smart division, right? Suppose if I say 5 and 2, no problem. If I say 5 and 0, there is a problem. Now I can avoid this by adding some new functionality at the rate. I'm wrapping this inside which one? Smart division. Now it means, you are calling division, but this division is wrapped inside what? Smart division. Means, is it called division 1 or not? Yes. You are calling division, but Python calls which one? Division 1 by sending N1 value and N2 value. And this N1 value and N2 value, it will check, is it N2 equal to 0? Yes. Then return 0. If N2 is not 0, then it will come to which one? Else. And call which function now? Division function, and return the result. Right? Now suppose I try to enter 5 and 2. So we should return this division 1 or not? Yes. So decorator is a function which returns another function. But is it decorator function should return a transformed function or not? Yes. And that is nothing but division 1. So 5 and 2, no problem. Okay, now 8 and 0, no problem, because it is written the value as what? 0. So division is wrapped. Division function is wrapped inside another function. What is that another function here? Smart division function. Okay, smart division function. Decorators. Okay, just try to understand what is a decorator is, right? Value is not, yes, according to, yes, yes, mathematics, according to mathematics, any number divisible with zero is what? Infinite value, right? Infinite value, but here no. In computers, it will try to generate which one? Error. Okay, because there is no infinite value, right? You can, if you want to define the infinite value, you have to use INF. INF is a value of type float. Okay. Now, if you want to return, now you want to return infinite value, you return it. What do you want? You want to return infinite value. What do you do it? If n2 is 0, then you'll say float of what is the value you are returning? Infinite. So INF is nothing but infinite value. Now, suppose number is 5 and 2, no problem, 2.5. Number is 5 and 0. What is the value? Infinite. Okay, so any number divisible with 0, return which value now? Infinite value. And infinite values of which type? Float. So INF is a string, right? And this string is represented in single quotes. And this will be converted into which type here? Float. Because always infinite values of which type? Float type, not integer type. It is of which type? Float type, right? Yes. Yes. Now this is called as a, yeah. This you can call it as which one here? Decorators. Decorator, generator, and one more is a, all these are special functions. And second, next one is what here? Closers. Decorators, generators, closers. Okay. Closer, the name itself, right? Closers. Okay, decorators are wrappers. Miss, you are right. You are wrapping one function inside what? Another function. You are wrapping one function inside another function, and that function wrapper is called as which one? Decorator. That function wrapper is called as which function here? Decorator function. So then what is a closer is? The name itself, right? See, all these are useful and all these are used. All these are useful and all these are used in application development. Like, because Python is having so many libraries, and those libraries provides the functions and function decorators also. Those provide functions and functions decorators. Okay. So I said no, function decorators avoids the redundancy of what? Code. Code redundancy, it avoids it. Because if you want to transform or change the properties of one function toward another function, and if you want to add some, if you want to perform certain operations based on the decorator, then you can do that with the help of which one? Decorators, right? So it is just like extending the functionality by adding some new features. Now there is one more function is there called a closer. What is a closer? Closer is a special function. Again, closer is also special function. So generator is for generating sequence of values. Again, so it is nothing but custom range. Okay. Now closer is there. Closer. Yeah, you can use more than one decorator function. That is called as, if you want to use, okay, more than decorator function means that is called as decorator chaining. Decorator chaining means it is like this. So can you use more than one decorator? Yes. So generally that is called as a decorator chain or decorator chaining, right? So sending one decorator as an input to what another decorator. Okay, one decorator is again decorated. See, generally function is decorated with decorator, and decorator is decorated with another decorator. So you are wrapping a decorator inside what another decorator. So that you can call it as which one, decorator chaining. Okay, so decorator chaining. So you can do this multiple decorator. You don't call it as multiple decorators, but rather than, for example, I write one function called display. Display is a function which display or print one message called what, Python. Now I want to decorate it. There is one decorator called draw stars. So I want to decorate this display with what, stars. Then I just write this is a decorator. So this is a function. So this is a transformed function whose name is what here, display one. And display one, it will try to display, okay, stars, and repeat these stars how many times, 20 times, and then call the function and print it. And this repeats this stars how many times again, 20 times. So I want to decorate this display function with the stars. Okay. Yes, you can call directly without main also, because why I write a main? Because I write all executable statements in main. So there should be some entry point, right? Entry point from where your program execution starts. So I try to put all executable statements inside main. Main also you can write all the statements one by one. Because we are including everything inside a function, even executable statements also be included in function, and that function is what, main, right? You can write it without that also, you can include all the statements. Now at the rate draw, now at the rate what is it, draw stars. At the rate draw stars, you can write like this. You can call directly which function, display. You can call directly display function, no problem. But instead of writing directly display function, we include these executable statements inside what, display in main. And then we called how many executable statements, only one. And your program execution starts from where, main. And main calls which function, display. And display is wrapped within what, draw stars. Display is wrapped within what, draw stars. Okay, fine. Now this is written. Written which one now, display one. Once you run this, now this Python is decorated with what, stars. Okay, now draw stars. Now there's one more. Draw, I'm saying draw. Now there's one more. Draw dollar. Now draw dollar is a decorator which takes the input as one function. Okay, it takes the input as a function. Now, is it decorator also one function or not? Yes. So that will receive the input as another function. And this function, which is called as display what, 2. And display 2 is there. What is this function here? Display 2. And this display 2 receive the input as one function or not? Yes. What is this display 2? It is a function which takes the input as this function. What is this function here? Draw stars. So actually see, draw stars will receive the input as which function? Display. Okay, display function. Now this draw stars receive the input as which function? Display function. Draw stars receive the input as display function, and draw dollar receive the input as which function? Draw stars. It will receive the input as which function? Draw stars. And this draw stars you are modifying inside which one? Display 2. What I'm doing here, print. I'm trying to repeat which one now? Dollars. How many dollars I'm writing? 20. And then I call which one? Display 1. Display 1 is nothing but function or not? Yes. Yes. After that again I write here print. What I'm saying here? Dollar. Dollar, and repeated how many times? 20 times. And then return. What is written? Display 2. Then what I'm doing is I'm trying to decorate. I'm trying to decorate display with the draw stars, and I try to decorate this draw stars with what? Draw. Draw. What is this? Dollar. Now, how many decorators are with the one function here? Two decorators. How many decorators are with this function here? Two decorators. Is it one decorator or two decorators? Two decorators. One is a draw stars and one more is what? Draw dollar. So what will happen if I run this? Display two. Not required actually this is. Because now dollars display dollar and then display which one? Star. Then Python and display which one? Star. And one more is which one? Dollar. Okay, right? So just try to understand this. A function can be decorated with multiple decorators. So how it is decorated with multiple decorators? By sending one decorator as input to what? Another decorator, and that you call it as decorator chaining. That is called as decorator chaining, right? So just see, now this is example. Somebody is asked, like, can you use multiple decorators? Yes. That is called as a decorator chaining here. Using multiple decorators. Using multiple decorators is called a decorator chaining here, right? Yes. If you see the output of this code, yeah, it is like this. Okay. So you can have multiple decorators, or you can a function can be decorated with one decorator. A function can be decorated with what? Multiple decorators. Like there is a draw dollar and one more decorator is what? Draw stars, right? Okay. Now there is one more function is there. What is that? Another function you have is a closer. There's one more function is there. And what is it? Another function you have is a closers. Now closer is also special function. Closer is also special function, right? Okay, right? So anyway, because this is a new topic, right? Now tomorrow we'll see how to work with which functions here? Closest function, right? So today we'll stop it here and tomorrow we'll continue with closest, right? Okay.